Hi folks, it's Mr. Ray here with our next lesson in grade 11 University Math. We are finishing off the rational expressions unit today with our part 2 lesson of adding and subtracting rational expressions. And as you hopefully remember from that lesson, that adding and subtracting rational expressions is more difficult than multiplying and dividing. Just because of the fact that you have to have common denominators for all your terms that you're adding together before you can actually add or subtract them. So we did some fairly basic adding and subtracting examples in the last lesson. So today we're going to step it up a bit with some more complicated examples. Okay, so example 1, you can see we're doing a subtraction and an addition of a rational expression. Remember, rational expressions have, instead of just having integers in the numerator denominator, they have polynomials in the numerator and denominator. So you can see we've got some multiples involving a on the bottom here and integers on the top. Okay, so again, just like last time, we see that these are not all the same. So we have to start working on a lowest common denominator. So if you examine what we have here, all our denominators are monomials. So we just need a monomial that we could get by multiplying each of these by something to get our target lowest common denominator. So you have to kind of break this into parts. I want to think about what my constant part of this, the number part. So I have a 5 and a 2 and a 1 in front of my a's. So what number is the lowest common denominator? Lowest common multiple for 5, 2, and 1? Well, 1 doesn't even matter. 5 and 2, the lowest common multiple would be 10. So I'll have that in my denominator. In terms of the a, okay, it's kind of the opposite of factoring. If I was to factor these three things, I'd take, they all have a's. I would pick the lowest exponent, which would be the 1. But for the lowest common denominator, I need to pick my highest exponent for any given a. So I have to work towards an a cubed. I can create an a cubed from an a or from an a squared. So that's what our variable part of our lowest common denominator will be. It'll be a cubed. So you're always thinking about what's the smallest multiple of all three of these that creates the same multiple for all three. So again, break it into the number part and the variable part. It's a lot easier that way. So we now know that we want 10a cubed on the bottom of all three. So I'll work towards that. First, I'll just put in my 10a cubed for all three, putting in the correct sign between the terms for adding or subtracting. This one's an addition. Okay, so just like last time, you look at, okay, so for this rational expression, I have a 5a in the bottom, and in order to create a 10a cubed, I'd have to multiply the 5a by 2a squared. So that means I also have to multiply the top, the numerator, by 2a squared. So I'll show what I'm doing there. So basically I multiply top and bottom by 2a squared of that. What do I have to do here? I start with a 2a squared. I wanted a 10a cubed. So I need one more a, and then need to multiply by 5. So in order to get the 10a cubed, I had to multiply by 5a. So I have to do the same thing on the top. Multiply the whole numerator by 5a. And similarly for the last part, I start with an a cubed. I want a 10a cubed. Well, I just have to multiply top and bottom by 10 in this case. So I had a 1 to start with, multiplying it by 10. So you can see each of these pairs of expressions are equivalent expressions, all resulting in the second line with the same denominator. That's our goal. Okay, so what I'm going to do now is create a single expression with that lowest common denominator of 10a cubed, and we're going to multiply and subtract or add as we need to. So as I read left to right, 4 times 2a squared, that's 8a squared. Then I'm subtracting 3 times 5a, so that's subtract 15a, and adding 1 times 10, which is 10. Okay, and that's it. We're done. There is a chance, and we'll see it later on, that you might look at that and go, "Hey, should I factor that? That's a quadratic. Maybe I should factor that." And sometimes you will. Sometimes you should, because there might be a factor from that could cancel with a factor on the bottom. But you can see from the denominator, I can't really factor this. This is just a monomial. So I'm never going to get a factor from this if this is indeed factorable that would cancel with anything on the bottom. So I just stop. There's no point in doing something for no reason. So this is our final simplified version of that rational addition and subtraction. And in terms of restrictions, well, the variable's a, and if you read the original question or anything along, it's really all about a. If a is 0 in any of these, that means that you're going to get divided by 0. So the only restriction is a can't be 0. Okay, so let's start getting into some factoring for these addition and subtraction. We haven't done too much of that yet. Now, I haven't had to ask this before because it was never necessary. But before we even think about a lowest common denominator, and I'm looking at this, I look at these denominators and go, I'm pretty sure I could factor both of these. So that's exactly what I'm going to do. So I'm not even thinking about lowest common denominators. So I can factor a 2 out of that denominator, keep the m on the top, and then I've got my minus 3. I can factor a 3 out of that expression, and that leaves us with an m minus 2, and that looks familiar from the last one. Now this one here, this looks more complicated than it should be. If you had one of your terms you're adding and subtracting, it's just an integer. Well, the first thing I would do is just put whatever that integer is over 1. And now at least it looks like a rational expression. At least, well, at minimum a rational number. And we're going to eventually turn it into a rational expression, which will combine with the other two. Now, in terms of, now at this point, we can actually look for the lowest common denominator. I would never even think about looking for a lowest common denominator till I've factored as much as I can on the denominator side. And now you can see the reason why is, well, there is something common there, and that's the m minus 2. So if I think about a common denominator, I'm going to have an m minus 2 as part of that. And now when I look at the number parts, you can see, well, I've got a 2, a 3, and a 1. Lowest common denominator for 2 and 3. You don't really have to incorporate the 1. Lowest common multiple, or for the denominator, would be 2 times 3, which is 6. So you put both parts in there. So my lowest common denominator is 6 times m minus 2. So now we use that. So again, just like before, I'm going to set up my rational expression. Still three different expressions. And now I'm going to put 6 times m minus 2 on the bottom of all three, and then work towards that. What do we need to do to make each of these have that same denominator? So here, you look at what you've got, take an inventory, and check off what you've got to make this. So we've definitely got the m minus 2, that's already there. Don't have to worry about that. I have a 2 here, but I want a 6. So that tells me I need to multiply in order to get from here to here, I had to multiply the denominator by 3, which also means I have to multiply the numerator by 3, so that's a 3m. Okay, same thing over here. I'm starting off with a 3 times m minus 2. I want to build a 6 times m minus 2. So checklist, I've already got my m minus 2 there, but I need a 6, and I've only got a 3, so that means I have to multiply the top and bottom by 2. So 2 times 3 is 6. Sometimes you, especially on these more complicated ones, you want to do a little bit more than we did in terms of how much work you do on each step. So just to keep the steps to a low number if we can, I've actually put the multiplication in there instead of putting 2 times 3. And then finally this last one, well, this one we're only starting with a 1. That means I have to multiply the whole thing by what we're trying to get. So I need to multiply the top and the bottom by 6 times m minus 2. So I have 6 times m minus 2 on the top. And that, you can easily see, well, it's the same thing on the top and bottom, so that's equal to 1. Now we can actually start combining into one rational expression with 6 times m minus 2 on the bottom. And we'll just read across the top to see what we get. So I've got a 3m minus 6, and then I've got plus 6m, and then 6, so that's 6 times negative 2, that's negative 12. And now we just combine all the like terms on the top. So I have 9m minus 18. And that's over 6 times m minus 2. And you'd probably be tempted to stop at this point. But like the last question I mentioned, where you ask yourself, well, this looks like I could factor it. Should I or shouldn't it? Shouldn't I? And the answer to that is it possible that a factor from here could be a factor that's already down here? And if you think there's a chance, you should factor this. So that's exactly what we're going to do. I can factor a 9 out of there. And I have an m minus 2 over 6 times m minus 2. And you can see we did it for good reason, because when I factored the numerator, I got one of the factors to be the same as one of the ones on the bottom. And for the first time, we're actually able to cancel some factors when we add and subtract. But again, you don't automatically just factor for the sake of factoring. You should intelligently say, is there a need to maybe factor this to see if I can cancel a factor that's already on the bottom? In this case, it was. So we did the factoring, and we were able to cancel that m minus 2 factor. We're left with 9 over 6, which is reducible to 3/2. Okay, so that's quite surprising sometimes when you see what you started with and see what you end up with. But you can see we did everything correctly, and things canceled out in the end, and we're just left with a rational number 3/2. Now, you may look at that and go, well, I guess there's no restrictions because there's no variable here. But remember, when we were multiplying, simplifying rational expressions, before you just make that decision, remember what we said about when you state your restrictions. You do it before you cancel any factors. So I could either look at this one or this one and say, well, there was an m minus 2 on the bottom at one point, and I have to consider that to be there for my restrictions. So m minus 2 means that m cannot be equal to 2. So that is a restriction. Okay, so you can see they're getting a little more difficult, but hopefully it's making sense. So another example here, this time we have two expressions, and both expressions have binomial denominators. So let's go about our business. Again, the first thing we do is always factor before we decide on lowest common denominator. So the factor for the first is 6 times x plus 1. Keep the x on the top. And then for the second expression, I can factor out of 4. And I have an x minus 3. So I know everybody was hoping it'd be x plus 1, but it wasn't this time. And usually it's not. So what did we do differently this time? So I guess I got to put my 5 on the top still. Now we look for the lowest common denominator for this operation, this addition of rational expressions. So I'm looking at my two denominators, and I want to come up with a series of factors that I would have that I could get. I could multiply something with each of these to get this lowest common denominator. So when you have a bunch of these binomial factors, you know that each of those different ones is going to be part of your lowest common denominator. So I know I need an x plus 1 as a factor in my denominator. I also know I need an x minus 3. So we've taken account of all the binomial factors, and now I look at my constants here. So I see I have a 6 and a 4. So I need a number that that's a multiple of 6 and 4, and that's going to be 12. You want to pick the lowest number. That's what the L stands for, lowest common denominator. You want the lowest expression that you can reach from each of these. So that's what we're going to build towards. So just like usual. So on the bottom of each expression in the denominator, I'm going to have 12 times x plus 1 times x minus 3, plus between 12 times x plus 1 times x minus 3. Okay, now what do we have to do? I want equivalent expressions here. So if I started with this and I want to end up here, what do I have to multiply the top and bottom by? Well, I can see from the number part, I have to multiply by 2. Okay, and I'll put my x right beside it, because the x was already there. Okay, and then when I look at my binomial factors, well, I already have my x plus 1, which I needed, but I'm missing an x minus 3, so I have to include that, multiply by x minus 3. So overall, I just multiplied by 2 times x minus 3 to get an equivalent expression with that common denominator. Okay, same thing on the other side. What do I have to multiply this by, on top and bottom, to get this on the bottom? So the number part, it's going to be multiplying by 3. Okay, and the 5 is already there. I don't want to forget about it, so let's put it in brackets beside. So far I've multiplied by 3, so I've got the 12 now. I've already got the x minus 3, but I need an x plus 1. So I have to add that. Okay, just remember when you're creating this section here, you're multiplying the top and bottom by whatever it takes to get the denominator to become your lowest common denominator. Now it's just a matter of simplifying, see what happens. So we combine them into one single rational expression with our lowest common denominator on the denominator. So as I read across here and multiply, I've got 2x times x, that's 2x squared. I've got 2x times negative 3, that's negative 6x. Over here, it's adding, so I've got, well, this is basically a 15. 15 times x, that's plus 15x. And 15 times positive 1 is 15. Okay, now I'm just going to simplify the numerator. It's really just combining the x terms. So I've got 2x squared plus 9x plus 15. Okay, and then on the bottom, so I'm looking at that. Now, there's a chance that maybe I should factor this because I've got these factors on the denominator, x plus 1, x minus 3. So it's, you could do it, but it turns out it doesn't, it's not going to, if you factor this, which I'm not even sure you can, it doesn't have x plus 1 or x minus 3 as a factor. So let's just go in with that knowledge that we didn't have to. So if that's going to be my final, I'm not going to do anything more with that numerator. Now on the bottom, I've got basically 12 times, binomial times a binomial. So if it's just a binomial times a binomial, in terms of you have two binomials, I actually want you to multiply those out. So you're going to do like a FOIL here. So I'll put my 12 out front, and I do this kind of in my head, x squared. I'm going to have a negative 3x and a positive 1x, so that's a minus 2x and a minus 3. Okay, yeah, and on the top there's no common denominator, so I'm just going to finish this off by multiplying the denominator part by 12. So I have 2x squared plus 9x plus 15 over 12x squared minus 24x minus 36. I'm just multiplying the 12 with each of those terms, and this is indeed our final answer. Now, as I've mentioned before in the previous lessons, I always want your final answer, your simplified answer, to have no brackets. Now, on the next page, I'm going to show you a situation where I'm going to override that rule. But for now, if it's just multiplying two binomials, I want you to do that. Now, in terms of restrictions, well, you can see all along here, we had these two factors on the bottom, x plus 1, x minus 3. So that tells you that x can't be negative 1 or positive 3, because it would make one of these factors 0. Okay, so let's continue on with one final example. And this one involves some trinomial factoring. Come down here. So this time we're using a y, but no big deal. It's just a different variable. Everything else is the same. Okay, so simplify this. Well, again, the first thing you try to do is factor the denominators as much as you can, if possible. And it's usually a pretty good sign if this is going to be a question. If we can't do anything with these, it's probably means you can factor them. So I probably wouldn't give you a question if you couldn't factor the denominators given two trinomials here. So I'm going to have a 4 on the top. Now this is a simple trinomial. So it's you're going to have two factors if it is factorable, which it is. Two binomials factors that both start with y, and the numbers we're looking for here, multiply to 6 and add to 5. Well, that's pretty easy, plus 3 and plus 2. So that's all factored. Move on to the next one. 5 on the top, subtraction between, and again, simple trinomial. So if it is factorable, two binomials that start with y, and the two numbers multiply to negative 12, add to negative 1. Well, that's minus 4 and plus 3. Okay. So we've got the denominator factored. Now we can think about lowest common denominator. Don't even think about lowest common denominator looking at something like that. So now we build our lowest common denominators. So just like last time, the first thing we looked at were our binomial factors. We want at least one of each. Okay. Now, you can see here, there's a y plus 3 in both. That doesn't mean I should write it here twice, because it's only in each of these once. If I had one of these that had two y plus 3 factors, my lowest common denominator should have two y plus 3 factors. But that's not the case here. There's only one in each, but that's definitely part of my lowest common denominator. And then I look for what else is down here in terms of factors. Well, I've got a y plus 2 and I have a y minus 4. So I have to build my new denominators on the next step so that they have that LCD. Okay, so I'm going to build my template here. So I'm going to have a y plus 3, y plus 2, y minus 4 on both of these. Okay, and now building, we know that's what we're going to have on the bottom. Well, what are we going to have on the top? So we look at each one separately. We go, okay, so in order for me to go from here to here on the denominator, I needed to multiply by y minus 4. So since I multiplied the denominator by y minus 4, I have to do the same for the numerator. So that's what we do. And over here, you can see, well, I've got the y minus 4, I've got the y plus 3, I'm missing the y plus 2. So in order for me to go from here to here, I have to multiply the denominator by y plus 2 and the numerator. So 5 times y plus 2. Okay, now we can actually start combining. That's a 2. So I'll put my single denominator now here. Hasn't changed from above, and now we're just basically reading along the top and trying to come up with what terms are on the top. So I have a 4 times y, so I have 4y, 4 times negative 4, negative 16. Now here, don't forget I got a negative sign. So what I like to do is just say, okay, you know what, I'll just think of this as a negative 5, and that'll give me what I should write here. So negative 5 times y, negative 5y, and negative 5 times 2 is negative 10. So now we just simplify the top. So I have 4y minus 5y, so that's negative y. And I have negative 16 minus 10, that's negative 26. And on the bottom, I have y plus 3, y plus 2, y minus 4. And this is where I break my rule, or at least adapt my rule about expanding, because it does say simplify. Simplify means no brackets, but for me to multiply 3 binomials is now quite a bit more work. So that's where I kind of draw the line. If you have something with 3 binomials that you have to expand, just leave it the way it is. So that's what we're going to do. Adapt our rules. And now we also have to look at restrictions on the variable y. So you can see all along we've had these 3 different binomials, which are all along here. So we can see from these 3 binomials that y can't be negative 3, can't be negative 2, and can't be positive 4. So negative 3, negative 2, and 4 are the restrictions. Okay, so you can see, you can have some fairly complicated additions and subtractions of rational expressions. I know in this homework that you've got here, it also includes some even more difficult ones where you're multiplying or dividing rational expressions and then adding or subtracting. So it's combining the 2 different types of operations, the ones where you have to have a common denominator and the ones where you don't. So I didn't have an example of that here, We'll probably do one or two in the class, but for now, let's just try to get a handle on these types of operations where it's either multiplying, dividing, or adding, subtracting, and then we'll combine those into some more difficult problems. We'll take those up as well. Okay, so that wraps up the rational expressions unit, and so hopefully this makes sense to you, and we'll see you on the next lesson. Have a great day.